the endocrine system. And it's a very interesting system. And we had made our way to this point right here, where we're looking at all these different hormones. And one of the things that I wanted you guys to do was to go check your textbook and look at those hormones that are in not only the anterior pituitary, but the posterior pituitary, and then the ones that are in the hypothalamus. Because one of the things about this is that we're going to find that there is control by way of the hypothalamus and by way of the parts of the brain. So we had talked about, for the most part, control is based on negative feedback. That becomes very important. Positive feedback is where we're going to run into some problems. One of the ones that we talked about was growth hormone. And growth hormone, I think, is a lot of people don't fully understand it because of everything that the growth hormone does. So that becomes very important to recognize growth hormone, when we need it, when it's released, and what it does. So now we're going to move into these other endocrine glands, because we've looked at the hypothalamus, we've looked at the pituitary gland, and we were kind of talking about it before class. So if you remember, the hypothalamus is that area that kind of looks like a W, with the pituitary that's kind of hanging by way of that stalk, the infundibulum, okay? We have the anterior pituitary, the posterior pituitary. One of the things that I mentioned as we were talking about it, had a couple of questions. If you think about it this way, the posterior pituitary, 2 hormones, that's it, okay? The ADH and the oxytocin. And they are based on a neuron. Remember how we have the 2 pathways, okay? One was the portal system, and the other one was this tract, T-R-A-C-T. Okay, so to the posterior pituitary is the tract, meaning axons. And the only 2 are the ADH and oxytocin. In the anterior pituitary, is based on the portal system, where chemicals from the hypothalamus are going to travel by way of the blood to the anterior pituitary. So that's our portal system. So it's by blood. So we have those chemicals from the hypothalamus to the anterior pituitary for the cells, okay, to either do something and then go to the other parts of the body, meaning our other endocrine glands. Ultimate control really comes down to hypothalamus and the areas of the brain. So these other endocrine glands, the pineal gland, the one that's kind of small towards the, back of the brain, it is larger in children than it is for us in adults. What we are associating with the pineal gland, the role in circadian rhythms. What is that? Alex?
The day and night cycles.
Our sleep wake cycles. If we were able to not be constrained by a 24-hour day and a 7-day week, which is a calendar put forth by Caesar many, many, many years ago, okay? Our own circadian rhythm would probably set to about a 25-hour day. I could use that extra hour, but anyway, we are forced into the circadian rhythm that we're in now. One of the things that happens at night, it synthesizes melatonin, what we tend to associate with sleep. And it synthesizes or makes this product from serotonin. Have you ever heard of that? Okay, it's one of those chemicals that they tend to associate with clinical depression, and one that they try to offset with medications. But at the same time, we're finding that these gut-brain peptides that we have are making it too. So they're doing a lot of study on some of these hormones. They think it could affect sexual maturation at the time of puberty. So it's one of those things that may, might, okay? We just don't know for sure. The thymus gland. Have you ever heard of T cells? How? Can you think of anything that you may associate T cells with?
Like T cells and B cells.
T cells and B cells. But when we hear T cells, we tend to associate it. You guys have heard of AIDS, right? Okay. That's what gets affected by that virus. T cells in our thymus gland. The thymus gland, it's going to play a part in our endocrine system, but it's also going to be a part of my lymphatic system and the immune system. So there are 3 systems that this gland comes into play with. Now, when we look at what it is, okay, when babies are born with very little immunity. They have a couple of weeks of immunity from their parent until they begin to start getting all of their vaccinations and so forth. So in the thymus, for children, it's huge. It takes up the majority of their chest cavity. Why? It's the site of maturation for T cells. So here, okay, so here's what will happen. In our blood, we will produce the white blood cells, the ones that are used for immunity. Now, what's going to happen? Some of these cells will be immature when they move into the bloodstream. They have to make their way to the thymus gland. The thymus gland releases thymopoietin, a hormone that is going to help those immature cells mature. So they become T cells and they migrate to other lymphatic organs. For example, the lymph nodes. Here, They will play a part in helping fight viruses and so forth that we will get exposed to. So as children with the big thymus, where they need to produce, or we need to produce a lot of these cells, it's going to allow, for example, when the child gets a vaccine, you know, they get exposure to something, this would create the immunity. That T cell goes, and B cells too, but T cells, since we're talking about the thymus, that T cell goes, sits in a lymph, most likely a lymph node, waits for something to come by that looks like what it should be attacking. For example, you get vaccinated for the polio virus. Okay, so if you were to get exposed, as it comes by, that T cell goes, oh, wait a minute, I'm supposed to attack this. And it does. You are immune. Same thing happens with, what kind of stuff do they get vaccinated for now? Measles, mumps, rubella, polio, yeah, okay, bunches of stuff, okay? So that if you're exposed, you don't develop it. So that means as the baby grows, okay, they are building their immunity. As we age, the gland involutes, gets smaller. Why? Like at this point in life, it's much smaller for me than it is for you.
Probably just been exposed to a lot of stuff, so we need to develop this immunities.
I've already developed a lot of immunities. I've been exposed. By the time we get, depending on how long you live, okay, but usually by about the age of 70 or so, it's hardly even functioning anymore. So the goal is hopefully you've been exposed to produce the T cells. So that one is very interesting because of the other systems it's going to play into, especially our immune system. The thyroid gland. How many of you have gone to the doctor? The doctor stands behind you and is doing this number, telling you to swallow while they're doing that. And it's almost like, okay, well, you're kind of choking me here, so how can I swallow? What they're doing is they're checking your thyroid gland. I have never really been able to palpate that in anybody. I guess it's just maybe a special skill or something. But it is the largest gland for adults. I know, we're all kind of like doing this number now, trying to see if we can feel it. Look what it does. It's busy. The primary effect of thyroid hormone increase metabolic rate. Oh, I would love it if it would increase my metabolic rate. But can things go wrong with the thyroid gland? We hear, usually associated with it, hypothyroidism, hyperthyroidism,